Today we're going to talk about using scale factors. We're going to use them in scale drawings or models, which is just an object or a drawing that has lengths proportional to the object it represents, okay? So what we're going to do is use the ratio of length of the model to determine the actual length of the object that it's representing. Okay, so below here we've got this map, and there's a few different towns on the maps, and this is a model or a representation of what it would look like actually. So what we want to find is the distance from, on this first one, Pineham to Menlo Fields. Well, what we can do is pay attention to what they scaled and see if we can use that to determine the actual length. If you take a look in this bottom left corner, they have our scale factor. Okay, they say that 0.75 inches is going to represent 6 miles. So what we want to do is go ahead and measure the actual distance here on our model and use that to convert to what the actual distance between two towns would be. Okay, so let's go find our distance on our model first. So pause the video and go find the distance from Pineham to Menlo Fields on your drawing to the nearest 16th of an inch. Okay, when I measured it, I got that the distance on the map here was 15/16 of an inch. Okay, if that's true, we can set up a proportion to solve for how many miles that would translate to. Okay, if that's true, let's take our scale factor. We're told that 0.75 inches represents 6 miles. Okay, well, on the other side of our proportion, we know we have 15/16 of an inch, and we're going to have our unknown. Well, since this is in inches here, we know that we want to put that on the top. We'll say 15/16 of an inch. That is representing how many miles. Okay, just like in the lessons before, we're going to cross multiply and divide to go solve for our unknown here. So 0.75x would be equal to, we'll take 6 times 15/16, which is really 5.625. Okay, last step to solve here is just dividing by that 0.75 on both sides. So x equals 7.5, and in this case, notice our unknown was measured in miles. Now what we can do at this point is ask ourselves if that makes sense, okay? We were told that 0.75 inches was 6 miles. So if we had 15/16, notice that's bigger than 0.75 inches. It's almost a whole inch. So that means that our total number of miles between Pineham and Menlo Field would have to be larger than 6 miles. And in this case, it is 7.5 miles, so it does make sense. Okay, so let's go do that same thing for the next one. We'll find the distance on our map here from North Park to Needham Beach in inches. This one turned out to be nicer for us. It was 2 inches. Okay, let's set a proportion just like last time. 0.75 inches is still proportional to that 6 miles. And on the other side, we're going to say 2 inches would correspond to how many miles then? If we cross multiply and divide again, that's 0.75x equals 12. And then divide by 0.75 on both sides. So x is 16 miles. Okay, on 3, we're looking at the distance from Eastwich to Denville. Okay, so Eastwich is up here in Denville. Go ahead and get that measured out. See if you can set up this proportion and solve it. Pause the video, take some time to do that. Okay, so for this one, if you had trouble multiplying for that second half of your cross multiplication, what you can do is take 1 plus that 7/16, that distance between these two towns, And that's going to give you that as a decimal, and then you can go and multiply that answer by 6. Okay, last thing to solve then is divide that by 0.75, which gives you about 11.5 miles between those two towns. So if you've noticed up there, before when we were doing ratios, in order to simplify them, we had to be measuring with the same unit. Well, with scale drawings, we don't need to have them in the same measure. So, for example, on the last one, we were comparing inches to miles. We didn't have to go convert them both to inches or both to miles to be able to do this. Okay, so scale factor is a unitless ratio in its simplest form. Okay, and they're always written so that the model length and the ratio comes first. So if we go back to our last example, the model length was this 0.75 inches compared to the actual length being 6 miles. So if on number 4 we have a dollhouse that is 15 inches tall compared to a real house that we know is 20 feet, can we write the scale factor for this model? Okay, again, we want to put the model first. Okay, so our model was the dollhouse, and that was 15 inches tall, and then our actual height was 20 feet. Okay, we want it to be unitless, and we want it to be in simplest form, so we just have to reduce that. Okay, unitless not meaning we drop off the unit, but unitless meaning they don't have to match up. Okay, so in this case, 15 and 20 both share a factor of 5, so when we take that out, we've got 3 inches on the top and 4 feet on the bottom. That is our scale for our model. 3 inches would represent 4 feet. Okay. Another thing I want to talk about is what's called a unit rate. Okay. For a unit rate, we want one of these numbers on the top of the bottom to be 1. Okay, and in this case, I'm going to get this one to be 1. Okay, in order to get something to be 1, we just want to divide out by that 4. Okay, so I'm going to divide both the top and the bottom by 4. So that means 3 divided by 4 on the top, which is 0.75. 3/4 is 0.75. And then I've got one solid unit on the bottom. 4 divided by 4 is 1. Okay, so the top, again, was inches, and the bottom was feet. So that means, just like before on our last one, 0.75 inches would represent 1 foot. Okay, now we want to decide how many times as tall as the actual house is the model. Okay, so in this case, let's look at it. Which one is going to be taller, the house or the model? Okay, if you think that through, obviously our model is going to be smaller. So how many times as tall as the actual house is the model? This number is going to be some sort of fraction because it's not as tall as our actual house. So what we want to do in this case is actually get them to the same unit. This is where we were doing ratios on day 1. We wanted them to be compared in the same unit because we don't know, it's not really 3/4 as tall because really this first one is measured in inches and the bottom is measured in feet. So we want to make sure that they're in the same ratio to compare how they relate. So our model here was 15 inches. Can we change 20 feet to inches? Well, we know that 1 foot is equal to 12 inches. So if we wanted to change our 20 feet into inches, we would just set up a proportion, okay, and we want to know how many inches is 20 feet. So we would just have to take 1 times 1, and then, or 1 times my x there, excuse me, and 12 times 20, which is 240. Okay, so now I'm comparing 15 inches to 240 inches. Last thing there is just reduce, so I've got 1 over 16. So my model is 1/16 as tall. Okay, let's see what number 5 is asking. We've got the length of a model train being 18 inches. Based on that, we want to compare it to the scale model of the actual train, which is 48 feet long. Find the scale factor. Again, scale factors, we don't have to have the same unit, so we just want to compare it, and then remember that the model always has to go first. We want to compare the model, then to the actual. So our model was 18 inches, and our actual train was 48 feet. Okay, last thing we want to do is just reduce, see if there's anything in common between 18 and 48. Okay, both of those share a factor of 6, so let's take 6 out of each of them. We're left with 3 inches on the top and 8 foot on the bottom. Okay, that is our scale factor. If we wanted to change it to a unit rate, again, we just want to get one of these to look like 1 being a single unit rate. Okay, so just like the last one, if we want to divide each of these by the bottom number, then I've got 3/8 over 1, or really 3/8 is the same thing as 0.375, and we add inches on the top, and we add feet on the bottom. Okay, a unit rate helps us when we're going to draw these, because if we have a solid number, especially if it's backwards, if we're drawing this, if we have a unit of 1, that's easier to draw than when we're working with other numbers here. Okay, so let's check out number 6. We've got the span of this bridge is 1,750 feet. The model of that bridge has a span of 42 inches, so a length of 42 inches. What is the scale factor of the model to the actual bridge? Okay, again, we always start with the model. So our model was 42 inches, and our actual bridge length was 1,750. Okay, again, that was measured in feet. Okay, so we just, again, want to look if we can reduce this at all. And in this case, a 14 goes into both of those. If you take 14 out of 42, you have 3 inches left on the top. And then go ahead and take 14 out of 1,750 for me. Okay, and that goes in 125 times. That is our scale factor. If we wanted to change that to a unit rate, I would divide each of these by 125. Okay, that obviously becomes 1. And on the top, we've got 0.024. Okay, again, that is called the unit rate. Okay, on number 7 here, an artist in Portland makes sculptures of dogs. The ratio of the height of a sculpture to the actual height of the dog is 2 to 3. If the height of the sculpture is 14 inches, find the height of the dog. Okay, so it gives us a ratio of the sculpture to the height, or in the case of all the problems we've been working with before, this is a ratio of the model to the actual. Okay, so therefore our scale factor would look like 2/3. Okay, based on that, if this is our model and this is our actual on the bottom, the other side of my proportion would have to represent the model on top and the actual on bottom. Okay, so the sculpture is 14 inches. That's my model, so I want to put that on top. And on the bottom, we're trying to find the actual height. That's my unknown. Okay, so we'll cross multiply and divide, and I've got 2x equals 14 times 3, or 42. I'm going to divide by 2 on both sides. So my actual height here is 21. Now in this case, it didn't really tell us up here, this 2 to 3, if we were comparing inches to inches or feet to feet, because remember, scale factors, they don't have to be compared to the same thing. But if we've got an actual height of 21, what do you think that's measured in when we're talking about the heights of a dog? Would it make sense for that to be inches, or would it make sense for that to be feet? Okay, and in this case, obviously, we're not going to have a dog that's 21 feet high. So this one, it would make more sense for that to be measured in inches as well. Okay, last example like this, we've got an architect drawing a scale of a new rectangular building. Okay, well the actual dimensions are 30 foot by 70 foot, and he wants his drawing to be 1/20th of the actual size. Okay, what must the dimensions of his drawing be in inches? Okay, well notice here we were given 2 actual lengths, and we have to go find 2 model lengths. Okay, so what we want to do is set up 2 separate proportions here based on the scaling. Well, the drawing is 1/20th of the actual size. Okay, so we're comparing 1 to 20. Now in this case, if it's 1/20th, we know that the model is smaller, and that makes sense for us. We don't make a model that's bigger in general. We scale it down so that we could look at it easier. Okay, so my scale here, this would be 1/20th. We can say the 1 is really my model here, and the 20 would be my actual. So based off of that, let's take one of the sides of our scale. We've got 30 by 70. Let's do one of it at a time. Okay, and 30, is that my actual or is that my model? What are we trying to find here? Well, if you notice, it says, what must the dimensions of his drawing be? That means I'm missing my model this time. I'm not given my model, I'm given the actual height, and we're trying to make a drawing from it. Okay, so what we want to do is put our unknown on top. How much would this model have to be if I wanted the dimensions to be 30 foot down here? Okay, so again, let's go ahead, cross multiply and divide. We've got 20x equals 30, and then divide by 20 on both sides. So x would be, hack off those extra zeros, 3/2, or really that's the same thing as 1 1/2, or 1.5. Okay, and notice it says, what must the drawing be in inches? So that's what we want to tack on for our label, inches. Okay, let's do the same thing for the other height, or the other length. We've got 1/20 equals, still don't know what our model is, but in this case we've got 70 foot being our actual length there. Cross multiply, we've got 20x equals 1 times 70, which is just 70. And then we'll go ahead and divide by 20 on both sides here. Again, you can just hack off those extra zeros, so x equals 7/2. Well, 7/2 is the same thing as 3 1/2, or 3.5 inches. Okay, so my dimensions would be, just like they wrote them up here, we're going to say 1.5 inches by 3.5 inches. Okay, the last thing we want to talk about here today is figuring out a scale so that we can make our own scale models or scale drawings. Okay, so we've got this example here. The Parthenon is a rectangular structure with dimensions of 100 foot by 230 foot. Okay, we're going to use those and your geometer to draw a scale model. Okay, then we're going to label it. Now, in this case, what I find the easiest to do is see if there is a scale that would be easy for us. Okay, we want to make it as easy as possible for us to draw here. So to do that, what I like to do is see if there's anything in common between those two numbers. Do they share a common factor? Now in this case, if you notice, they both end in 0, so we know they have a common factor of 10. Okay, well let's see what happens when we divide both of those by 10. I've got 100 divided by 10 is 10, and 230 divided by 10 is 23. Now, for us, if we're using our geometer, and since we're working with feet, the most common thing to compare that to is using inches. Would it be possible for us to fit 10 inches by 23 inches on this paper? Okay, obviously not in our case here. So what we want to do is go find some numbers that would be able to fit. Okay, so let's, instead of dividing by 10, let's try dividing by 20 instead. So if I take 230 and divide that by 20, okay, I get 11.5. Okay, well, that would fit on our paper because 11.5 papers are 8.5 by 11. Well, I guess it wouldn't fit on our paper. Okay, but if you look at your geometer, it only goes to 8 inches anyway. Okay, so we don't want to have to worry about doubling up our geometer. We want to pick something less than 8 inches. So let's keep going. So I'm going to say instead of dividing by 20, let's divide by 40. Okay, I've got 5.75. Okay, that's a decent number to try to draw because 5.75 for us, 5.75 inches is 5 3/4. Okay, that's something that we recognize. Let's see if we divide 100 by 40, if that's nice as well. 2.5, that's 2.5, that's something we can draw easily. Okay, well the factor that I picked was 40, so I'm going to say that 1 inch here represents 40, and what is my actual building measured in? Okay, here we're measured in feet, so I'm going to say 1 inch represents 40 feet. Okay, if that's true, we already did it here a little bit ago to test it, but what we're saying is 1 inches is 40 feet, so if I'm trying to set up a proportion here, to find out what my scale would be, I would say x, that's my unknown, has to be 100 feet. Okay, notice inches and inches together, feet and feet together. So this is where that 100 divided by 40 comes from, because when I set up this proportion, I cross multiply and then I'm dividing by that 40 on both sides. Okay, same thing with the other one. 1 inch is 40 feet, and how many inches would represent then 230 feet? Cross multiply and divide, so I've got 40x equals 230, divide by 40 on both sides, so x equals, okay, when we divided that out here, the first one we've got 5.75, and the second one was 2.5. Okay, so when we divide 230 by 40, we got 5.75, and when we divided 100 by 40, you get 2.5. Okay, so you would take your geometer at this point and draw a scale representation of this rectangular building, the base of it, okay, with the long side being 5.75 inches, okay, which on our geometer is going to be 5 3/4 inches. And then the other side being 2.5 inches, or on your geometer, 2 1/2 inches. Okay, this is one example of the many different options that we could have picked for scale factors. You might have to play around with different numbers to see which ones end up as nice numbers that we can draw easily on our model.